Hi everyone, welcome back to our YouTube channel Set Education. In our previous video, we have seen several examples on quicksort algorithm. In this video, we are going to write the algorithm for the same. So if you remember that, let's say I take an example. If I have, let's say 12, 8, 10, 6, 3. This is my array. So you remember what we used to do? We started with writing what is pivot, that is our first element, and if it is greater than a of I, and we used to initialize I as low and j as either this or I have taken another example where we used to introduce infinity and j to this and considering this as high, right? So if pivot is greater than equal to ai pi, if it is true, we used to increment I. If it is false, we need to check whether pivot is less than a of j. If this is true, we need to decrement j. And if this is false, what we used to do? We need to do swap. Now, how we used to do swap? We used to check whether I is less than j. Then we used to swap a of I and a of j. It means that a of I and j has not crossed each other, or I has not crossed each other to be very specific. And in case I has crossed j, we need to swap pivot element with the a of j. By this, we used to get the right position of pivot in the array. If you remember it, right? So this is how we used to do it, right? So let's write an algorithm for the same, or if you want me to just do this example and then we want to write an algorithm, that we can do. Okay, so let's do that. So this is my pivot. I'm considering first element as pivot, and I'm initializing I as this and infinity as j. Okay, so leave this. This will take, right? Now what I used to do, 12 greater than 12, condition is true, increment I, correct? So your I changes to this. Now 12 greater than equal to 8, this is condition is again true, increment I. So I becomes this. Now 12 greater than equal to 10, condition is true, increment I. You incrementing I. Now 12 greater than or equal to 6, condition is true, increment I came here. 12 greater than equal to 3, condition is true, increment I. So I came here. 12 greater than equal to infinity, condition is false because infinity is more. If this is false, what we need to check? We need to check whether pivot is less than a of j. So what is pivot? 12 is less than infinity, condition is true. If condition is true, decrement j. So your j comes to this. Now again, is 12 less than 3? Condition is false. Now condition is false means you need to talk about swapping. Now whether I have crossed j, yes, I is here, j is here, or even I talk about in terms of indexes 0, 1, 2, 3, 4, 5. I is index 5, j is at index 4, means I is greater than j. So this condition is false, so you need to swap pivot element with j. So your thing becomes 8, sorry, 3, 8, 10, 6, 12. So your pivot element came at the right position. This is the position. So if you see all the elements left to it are less than it. If in case there are more elements and it is coming at the right of this pivot element, they will be greater than this. This is how this algorithm works, right? So let's write the code for this, right? So simple thing. First you need to do pivot. You need to assign a pivot. This thing I already told you in the basic video, if you remember, right? The two videos above to it. I have talked about how it works. It works on three fundamental, that is pivot. Second, it is on partition, and third thing, it works on the what you call as recursive call, right? So let's quickly do that. So what we need to do, we need to write a first partition function, okay? So partition function again, you need to say this is low and this as high, correct? So let me write the partition of low and high from low to high, right? What is your pivot? pivot element is your first, right? I'm considering this as first element, that is A of low. So my pivot is A of low. Now I'm initializing I as low and J as high. So I as low I'm initializing and J as high, correct? So I have indexes this I and this as my J, right? Then what I do, while I is less than J, what I do, I increment I till when this condition. What is that condition? Remember this condition, right? So while A of I is less than P1. Is that correct? Is that correct? Otherwise, what you do? What you do? You decrement J till when condition is pivot is less than A of J. So you can write while A of J is greater than pivot. Otherwise, right? Then what you do? Then you check for the swap conditions. Then you check for the swap condition. So, okay, I'll remove this. I don't know from where it came. Okay. So if I is less than J, what you need to do? You need to swap A of I and A of J. It means I have not crossed J. Otherwise, else, else, what do? You swap A of L, A of J, right? And you can return J. Now, if you're returning the value of J, this is how you will get a partition. Partition means, for example, your array is this. Okay, sorry. If your array is something like this, and if this is a pivot element, you will get a pivot element and some partitions here and here. Now you have to again apply a quick sort here, right? Quick sort here. So you will, so it is J position, right? This will be a J position, remember, because you are swapping what? See here, you are swapping pivot and J, and pivot is this first element, and somewhere J will come here. So you will swap. Are you getting it? So we need to write one more function called as quick sort. Now quick sort also work from low to high, and if low is less than high, then what you do? Your J, right? This is nothing but partition of L comma H. And again you apply just the recursive call, that is quick sort, from where to where? L to J, and then J plus 1 to high. That is if you have divided this and this is a pivot. So from here to here you have to apply 1, and then from here to here you have to apply 1. Are you getting it? And that's it. Now you can write a swap function because we are using one swap here. So you can write that swap function as well. So I'm not writing a temporary variable, you can write it. Okay. So this is how it looks like. Actually, ideally you see, I have written this algorithm itself from the day one. If you're seeing my videos, I'm using the algorithm only. Now it is the way in which we are writing it, right? So in our next video, we are going to derive the time complexity, space complexity for best, average and worst cases. And then again, we'll take few more examples for your practices. Thank you.